Welcome students. We are going to start our video lecture series on the subject of machine design. This subject has got the code ME303 and is taught in the 5th semester of Mechanical Engineering branch at Suresh Gyan Vihar University, Jaipur. We are going to start with Unit 1, lecture number 1, and the topic which we are going to discuss is the introduction to machine design. See, this machine design subject is very important for a mechanical engineer, and therefore it has to be discussed very thoroughly. And for that, first of all, it is very important to get a briefing of this subject, that what is particularly this machine design subject. Myself, I am Shri Krishna Mishra, assistant professor in the mechanical engineering department of Suresh Gyan Vihar University, Jaipur. Now, in this introduction, many things are to be discussed. Like what? Like what is the design procedure? Then after, what are the different what are the different considerations taken while designing any machine element? All right, and in that particular consideration, we will have to get deep into that. Then there are different types of forces which act on a particular machine element during its use. So we will have to consider all those forces, all those loads which act on a element of a machine during its use. And after the assessment of all those forces, we will have to consider them in the design, and therefore this aspect has to be discussed. Then after, the materials, there are many types of engineering materials. We will have to go through, first of all, the properties of those particular engineering materials, and then after, on the basis of the properties needed for our personal use of a particular machine, we will have to choose that particular material. So that is also important. So step by step we will move into that. All right. So our objectives of today's lecture is to understand the concept of machine design. It is very important to understand the concept of machine design for a mechanical engineer. It is very important to pay full attention on this subject. Designing is always considered to be a very charming field, but if you want to if you want to get thorough understanding of this subject, then you will have to go deep into the learning of this subject. Then after, to study about the design procedure. Now, design has got a particular set of steps to be followed. It is not a way that the last step will be performed firstly, and then after first step can be performed later on. This doesn't happen in the designing. Design is a systematic approach which has to be followed. So that also is our objective, to get the understanding. Then there are different types of considerations, as I have told you, many considerations like aesthetic considerations, ergonomic considerations. All right, and then manufacturing consideration. Many considerations are taken for while designing a particular machine, while designing a particular machine component. So you will have to develop the understanding of the importance of these considerations. And the last objective is to develop a learning about designing a machine element, to develop a view about the designing a machine element. So I hope you are getting the overview of the objective of the whole subject as well as today's lecture. And so let's move into the lecture. Uh, let's move into the today's introduction part. And after the completion of this today's lecture, I am going to discuss the MCQs, multiple choice questions, with you all, so that we can assess how much understanding we have got about the subjects. And later on, I will tell you about the various references you can take while studying by yourself. All right. So let's move into the lecture number 1. The name of the subject is machine design. So we should know what is machine design. Machine design is defined as the use of scientific principles, technical information, and imagination in the description of a machine or a mechanical system to perform specific functions with maximum economy and efficiency. In other words, we can say machine design is the creation of plans for a machine to perform the desired function. Now, we can say that the machine may be entirely new in concept, or it can be some improvement of already existing concept. In a way, we can say that machine may be entirely new in concept, performing a new type of work, or it may be more economically perform the work that can be done by an existing machine. It may be an improvement or enlargement of an existing machine for better economy and capability. Now, a designer uses principles of basic and engineering sciences such as physics, mathematics, statistics, and dynamics, thermodynamics, and heat transfer, vibration, and fluid mechanics. Some of the examples of these principles are Newton's laws of motion, D'Alembert's principle, Boyle's and Charles' law, Carnot cycle, and Bernoulli's principle. So, the definition of machine design contains the following important features which I have told to you. Now, we can also say that machine design is the creation of plan for a machine to perform the desired function. As I have already told you, it can be new in concept, performing a new type of work, or it can be an improvement on existing work. Or we can say that it may be an improvement or enlargement of an existing machine for better economy and capability. Now, coming into the procedure of machine design. The basic procedure of machine design consists of a step-by-step approach from given specifications about the functional requirement of a product to the complete description in the form of drawing of the final product. Now, these steps are interrelated and interdependent. As you can see in the diagram also, you can see a logical sequence of steps that are usually common to all the design projects. As I've already told you, these all steps are interrelated and interdependent, each reflecting and affecting all other steps. The following steps are involved in the process of machine design. What are the steps? As you can see in the screen also, first is the market survey, then comes design specifications of the product, third is study alternative mechanisms for product and select proper mechanism. Then after doing it, the step comes is to prepare general layout of configuration and select joining methods between individual components of product. Then after it comes the design of individual components, and then after lastly, when everything is completed, we prepare assembly and detailed drawings and modify drawings after testing prototype model. I hope you have got the whole process. Now coming into the step number 1. Step 1 is what? Step 1 is product specification. The first step consists of preparing a complete list of the requirement of the product. The requirement include the output capacity of the machine and its service life, cost also, and as well as reliability. In some cases, the overall dimension and weight of the product are specified. For example, while designing a scooter, the list of specifications that we all know will be as follows. We all know the fuel consumption of a scooter is near about 40 kilometer per liter. Then after comes maximum efficiency, that is 85 kilometer approx. I am taking average 85 kilometer per hour, carrying capacity 2 persons with a 10 kg luggage. All right, and the overall dimensions will be what? With approx I am taking 700 mm length, 1750 mm height, 1000 mm. All right, so in similarly the weight will be approximate 95 kg. Cost will be approximate. I am taking approximate value near about 50,000. Now in consumer products, external appearance, noiseless performance, and simplicity in operation of controls are important requirement. These things are always kept in mind while designing any product. Depending upon the type of product, various requirements are given weightage and a priority list of specification is prepared. The step number two, coming into the step number two, define specifications of product. Define the specification of product. After careful study of the requirements, the designer prepares rough sketches of different possible mechanisms for the product. For example, while designing a blanking or piercing press, the following mechanisms are possible. Number one, a mechanism involving the crank and connecting rod, converting the rotary motion of the electric motor into the reciprocating motion of the punch. Number two, a mechanism involving nut and screw, which is a simple and cheap configuration but having poor efficiency. Number three, a mechanism consisting of a hydraulic cylinder, piston, and valves, which is which is a costly configuration but highly efficient. The alternative mechanisms are compared with each other and also with the mechanism of the product that are available in the market. An approximate estimation of the cost of each alternative configuration is made and compared with the cost of existing product. This will reveal the competitiveness of the product while selecting the final configuration. Now, while selecting the final configuration, the designer should consider whether the raw materials and standard parts required for making the product are available in the market. He or she should consider whether the manufacturing process required to fabricate the non-standard components are available in the factory or not. Depending upon the cost competitiveness, availability of raw material, and manufacturing facility, the best possible mechanism is selected for the product. Now, coming into the step number three. That is, step number three is what? Step number three is study alternative mechanisms for product and select proper mechanism. In a way, we can say that it is discussing about the layout of the configuration. The next, this step is a design procedure to prepare a block diagram showing the journal layout of the selected configuration. For example, the layout of an electrically operated overhead traveling crane will consist of the following components. First, electric motor for power supply. Second, flexible coupling to connect the motor shaft to the clutch shaft. Third, clutch to connect or disconnect the electric motor at the will of the operator. Gearbox to reduce the speed from 1440 rpm to approx around 50 rpm. Fifth, rope drum to convert the rotary motion of the shaft to the linear motion of the wire rope. Sixth, wire rope and pulley with the crane hook to attach the load. And lastly, final step, brake to stop the motion. In this step, the designer specifies the joining methods such as riveting, bolting, or welding to connect the individual components. Rough sketches of the shapes of the individual parts are prepared. Now, this was step number three, coming into step number four. Step number four is the design of individual components. We are going to design the individual components in this step. So, what will be the complete description of this step? Let me tell you. The design of individual components or machine element is an important step in the design process. It consists of these stages which I am telling you. Number one, determine the forces acting on the component. Number two, select proper material for the component depending upon the functional requirements such as strength, rigidity, hardness, and wear resistance. Number three, determine the likely mode of failure for the component and depending upon it, select the criteria of failure such as yield strength, ultimate tensile strength, endurance limit, or permissible deflection. Then number four, determine the geometric dimensions of the component using a suitable factor of safety and modify the dimensions for assembly from assembly and manufacturing considerations. This stage involves detailed stress and deflection analysis. Whole of the deflection analysis as well as stress analysis is done in this particular stage. The subjects like machine design or elements of machine design covers mainly the design of machine elements or individual components of the machine. Now coming into the step number fifth, which is the final step. After completion of whole of these steps and completion of whole of the design of the machine, its drawing is prepared, and therefore the step number fifth is preparation of drawing. The last stage in our drawing process is to prepare drawings of the assembly and the individual components. On these drawings, the material of the component, its dimension, tolerance, surface finish grades, and machining symbols are specified. The designer prepares two separate lists of the component: standard components to be purchased directly from the market and special components to be machined in the factory. So, so I was telling you that in the final stage, the designer prepares two separate list of the component: standard components to be purchased directly from the market and special components to be machined in the factory. In many cases, a prototype model is prepared for the product and thoroughly tested before finalizing the assembly drawings. It is seen that the process of machine design involves systematic approach from known specifications to unknown solutions. Quite often, problems arise on the shop floor during the production stage, and design may require modifications. In such circumstances, the designer has to consult the manufacturing engineer and find out the suitable modification. Now coming into the whole of the design process. First, complete having a revision. First was product specification. Step number two, selection of the mechanism. Here, rough sketches of different possible mechanisms for the product was prepared. What was the first step? First step was preparing a complete list of requirement of the product. And in step number three, what we have made a layout of the configuration. We have made the layout of the configuration to prepare a block diagram showing the general layout of a selected configuration. Then after, step number four was to design of individual components. In it comes the determining the forces acting on the component. Second, selecting proper material for the component. Thirdly, determining the likely mode of failure for the component, and Depending upon it, select the criteria of failure, such as yield strength. So this was the design process which I elaborated, and in short I have told to you. What was the fifth step? Fifth step was the preparation of drawing. The last stage in the design process is to prepare drawings of assembly and the individual component. On these drawings, the material of the components, its dimension, tolerances, surface finish grades, and machining symbols are specified. So this was the complete step. Now, what are the basic requirements of machine element? What are the basic requirements of machine element? A machine consists of machine elements. Every machine has individual components which are known as elements, machine elements. Each part of a machine which has motion with respect to some other part is known as machine element. This is the definition of machine element. Each part of a machine which has motion with respect to some other part is known as machine element. In order to achieve this objective, the machine element should satisfy some requirements. So, what are those basic requirements which the machine element should satisfy? First is strength, very important. Any machine element which is used in designing of a machine should have adequate strength. Strength means it has the ability to withstand or bear the external forces. All right, in strength comes its tensile strength, compressive strength, shear strength. These all strengths should be there in the material used for making the machine element. Then the material should be rigid enough. It should be resistant to deflection, means it should not get distorted easily when any load is applied on it. Third comes the wear resistance. It should be free from any wear or tear. Fourth is minimum dimension and weight. It should not be bulky, it should be light in weight. And it should not be of large size, otherwise, it will make the whole of the machine larger in size. Then comes manufacturability. Whatever is the dimension, they should be selected for a machine element in such a way that it could be easily manufactured in the production department. Then comes the safety issues. There should not be any such type of issues related to machines element design that will cause any safety problems, any hazards. Like if there are some sharp corners which are there in the machine element, then it can cause chances of any accident or cutting. It can cause chances of cutting. It should be it should be smooth. So these are the safety considerations which are taken. These are the safety considerations. Then comes the conformative standard. All machine elements should be of some standard shape and dimension, so that whenever during its use, whenever the machine is being used by the user, if there is any problem to change that particular machine element, then that is easily available in the market. The other reason is that standardization is very important. If there is use of standard parts, then any spare parts needed by a machine assembly unit can be obtained easily. Then is the other requirement, the other basic requirement is reliability. Component should be reliable. It should be reliable. As you all know, reliability is an important criteria. Whenever we buy anything, we need that the component or the machine which we have bought should be reliable. It should not fail. All right. So reliability is also a criteria. Then maintainability, the maintenance cost should be low of the machine element. It should not get uh, it should not get damaged frequently. Then comes the minimum life cycle cost, means the total cost including the purchasing cost, then after its repairing cost in between if there is any failure, the total cost including these all costs, the total life cycle cost should be minimum. So these are some basic requirements of a machine element. Now, machine elements can be classified in two groups: general purpose and special purpose machine elements. General purpose machine elements include shafts, couplings, clutches, bearings, springs, gears, and machine frames. Special purpose machine elements include pistons, valves, spindles, etc. Special purpose machine elements are used only in certain types of applications. On the contrary, general purpose machine elements are used in a large number of machines. The broad objective of designing a machine element is to ensure that it preserves its operating capacity during the stipulated service life with minimum manufacturing and operating cost. In order to achieve this objective, the machine element should satisfy the following basic requirement which I have told you. Strength. All right, a machine should not fail under the effect of the forces that act on it. It should have sufficient strength to avoid failure, either due to fracture or due to general yielding. Second, rigidity. A machine component should be rigid, that is, it should not deflect or bend too much due to the forces or moment that act on it. All right. Now, wear resistance. Third point. Wear is the main reason for putting the machine part out of the order. It reduces useful life of the component. Wear also leads to the loss of accuracy of machine tools. There are different types of wear such as abrasive wear, corrosive wear, and pitting. Surface hardening can increase the wear resistance of the machine components such as gears and cams. Fourth is minimum dimensions and weight. A machine part should be sufficiently strong, rigid, and wear resistant, and at the same time with minimum possible dimensions and weight. This will result in minimum material cost. All right. Coming into the point number fifth, which I have told you, what was the point number fifth? Point number fifth was manufacturability. Manufacturability is the ease of fabrication and assembly. The shape and material of the machine part should be selected in such a way that it can be produced with a minimum labor cost. Sixth point, safety. The shape and dimension of the machine part should ensure safety to the operator of the machine. The designer should assume the worst possible condition and apply therefore fail-safe or redundancy principles in such cases. Then comes the safety. The shape and dimension of the machine parts should ensure safety to the operator of the machine. The designer should assume the worst possible condition and apply fail-safe. This I have already told you. Now, the other point is conformity to standard. Means there should be some standard used. A machine part should conform to the national or international standard, covering its profile, dimension, grade, and material. Eighth part is reliability. Reliability is the probability that a machine part will perform its intended functions under desired operating conditions over a specified period of time. A machine part should be reliable, that is, it should perform its function satisfactorily over its lifetime. The other point, ninth point, was maintainability. A machine part should be maintainable. Maintainability is the ease with which a machine part can be serviced or repaired. The last point is minimum life cycle cost. What was minimum life cycle cost? Life cycle cost of the machine part is the total cost to be paid by the purchaser for purchasing the part and operating and maintaining its overall lifespan. Now, these were all the functional requirements of a machine element. Standardizations. As I have already told you, this was also a point minimum basic requirement of a machine element. So what was a standardization? Standardization is basically the norms for using standard shapes. It is defined as obligatory norm to which various characteristics of a product should conform. The characteristics include materials, dimensions, and shape of the component, as well as method of testing and method of marking, packaging, and storing of the product. A standard is defined as a set of specifications for part, materials, or process. So, standardization, this is a very important step while designing. If your parts are not of a standard dimensions, then the machine or the product which you are going to design and bring to the market will not be feasible, and it will not be used by the consumer. All right, there are always standards for everything. There are standards for materials, their chemical composition, mechanical properties, as well as heat treatment. All right. So the, there are standards for everything. There are standard for everything. As I have told you, standard for material, their chemical composition, like IS 2110. This is a standard. It specifies seven grades of grey cast iron, designated as FG 150, FG 200, FG 220, and similarly the other names. The number indicates ultimate tensile strength in Newton per mm square. So these are the grades. For example, again, alloy steel designated by 55 CR3 means it is also a standard in which there is a particular percentage 0.5 to either 0.6 percentage of carbon, similarly some percentage of silicon, manganese, and chromium. All right, these all are the components, individual components from which alloy steel is prepared. Then there are standards for shapes, also shapes and dimensions of some commonly used machine elements like bolts, screws, nuts, rivets, belt and chain, ball, and roller bearing. The others, there can also be more like wire ropes, keys, and splines, etc. For example, IS 2494 specifies dimension and shape of cross section of V belts for power transmission. So you have full machine design data book in which the dimensions, the standard dimensions are given to you. Similarly, the third, there are standards for fits, tolerances, and surface finish also. Selection of type of fit for different application is given in IS 2709 on guide for selection of fits column. So from there you can get all the standards that are used for fits and tolerances. Then comes the standard for testing of products. These standards, sometimes called codes, give procedure to test the products such as pressure vessel, boiler, crane, and wire rope, where safety of the operator is an important consideration. IS 807 is one of such code, which is used for design, manufacturing, erection, and testing of cranes and hoist. Then comes the standard for engineering drawing of components. For here, this is given by Bureau of Indian Standards. All right. A standard, basically overall we can say what is a standard. A standard is defined as the set of specifications for the part. So I hope you have got the understanding of whole of the concept told to you. Everything is now crystal clear in your mind that what is the design procedure taken while designing any machine element. All right. And the design process that is followed. All right, the basic procedure of machine design like market survey, specifications of the product, and these all things are clear to you. All right, and the definition is also very clear to you that what is machine design? It is the creation of plans for a machine to perform the desired function. And it can also be, this should also be kept in your mind that doesn't that it always doesn't mean that creation of plans or means something new. It can be an improvement or enlargement of an existing machine for better economy. All right. So now I am moving into the multiple choice questions part so that we can assess that whether we have learned nicely or not. So the first MCQ, the first multiple choice question is in front of you. The question says that the three basic types of failure are A. Failure by elastic deflection. B. Failure by general yielding. C. Failure by fracture. And D. All A, B, C. Now, we all know that different material fail by different methods. Like in case of brittle materials generally do not yield. There is no plastic deformation in brittle materials. They directly gets broken into two pieces. If this is the material, brittle material, it will not elongate. It will directly get broken into two pieces. All right. So in brittle material, in the case of brittle materials, there is no plastic deformation. So they fail due to directly by a fracture. So we say that brittle material fail by fracture. So for option C is the failure mode. All right, failure by fracture. Option B, in case of mild steel or the materials which are ductile, what happens whenever a material which is ductile, when it is elongated, it is stretched. It is stretch means why it is stretched, because there is some plastic deformation. There is some plastic deformation due to which there is yielding that happens, and due to yielding a neck is formed, and finally at last the material is deformed. So this particular failure is known as yielding. What is it is known as? This is known as yielding. This is known as yielding. All right. This particular failure is known as yielding. So this is also option B is also a failure mode. Then after, if any material is loaded in this way, means this is the material and this is the direction of force. Now, due to this force, if this material gets deflected in this way, if this material or this particular component gets deflected in this way from its normal position, so this type of failure is known as elastic deflection. So elastic deflection is also a failure. All right, all these three are the basic types of failure. So we can say that all the options A, B, C are correct. Means option D, which includes all the above three options. This is the correct option. All of these is the correct option. So for MCQ one, the correct answer is for MCQ one, the answer is answer D. All right. Coming into the MCQ multiple choice question number two. Now the multiple choice question two says that pitting is a what is pitting? Now pitting, as I have told you, that this is this is this is a surface type failure. This is a surface failure when again and again, if load is applied on any object. For example, pitting you can see in case of gears also. In case of gears, what happens? The teeth of two different gears in the gear arrangement, when the teeth of two different gears, they regularly strike each other. They regularly strike each other with a force. Like for example, if this is gear number one and this is gear number two, then this gear number one, when it rotates, it takes with itself the gear number two with the help of this combination. And now this regularly happens. When this regularly happens, there is some pit developed here. There is some pit developed in these teeth. So what we can say about this pitting? Pitting is what? An internal crack? No. Thermal degradation? Sort of, but not exactly. Process? No, we can say it is a surface fatigue. Surface, what is fatigue? Fatigue is generally what? When regularly, again and again, the same load is acting after frequent intervals. Then we say that the fatigue load is acting, means the load which is not constant, which changes with respect to time, and the failure due to this type of load, the failure due to fluctuating load is a fatigue failure. So pitting is basically what? Pitting is a fatigue failure. So the correct answer will be your option number D, that pitting is a surface fatigue failure. What is pitting? Pitting is a surface fatigue failure. So always keep this in mind. Now coming into the MCQ number 3. What does this MCQ number 3 say to you? MCQ number 3, the question number 3 says that in order to achieve the objective, the machine element should satisfy. Machine element should satisfy, see, all these qualities. Strength is also needed by the machine element. Machine element should also be rigid. Machine element should be wear resistant. And so if all these three qualities are important for a machine element, you can't ignore these all three qualities. Means option D is the correct answer. Option D is the correct answer. Option D is the correct answer. Why? Because strength is also important for a machine element. Rigid is also a property needed by a machine element. Also, the machine element should be wear resistance. And lastly, therefore, all the three options are correct. So D will be taken as the correct answer. Coming into the MCQ number 4. Now the MCQ multiple choice question number 4 says that the minimum possible dimension and weight of any material component or machine element, the minimum possible dimension and weight increases cost of product. Minimum possible dimensions and weight means if you keep the dimension and weight of a machine element less, what your cost will increase or the cost will decrease or there will be no effect on the cost, or the cost will also decrease as well as increase. So we all know that the whole purpose of designing is to keep the whole purpose of designing is to keep minimum possible dimension and weight of the designed product. Therefore, why it is done? Because in order to have the cost of product less, this thing is done. So the whole purpose of minimum possible dimension and weight is to decrease the cost of the product. So minimum possible dimension and weight, it decreases the cost of the product. Here it is written A, it is not E. A, you write it as B. B is the correct answer. You corrected, B is the correct answer. This is a twister. I have written A so that you can get confused. It is not A, it is B. B is the correct answer. Now coming into the MCQ number 5. The MCQ number 5 says that the total cost to be paid by the purchaser for purchasing the part and operating and maintaining a machine over its lifespan is known as C. The total cost given by the purchaser for purchasing as well as operating any machine as well as maintenance of that machine throughout its life, whatever is the cost given by the purchaser, what is the term used for that? That is stock cost, life cycle cost, machine cost, or service cost. The correct one is the life cycle cost. The technical term used for the total cost of a particular product through its from its purchasing cost to the its maintenance cost. That is known as the life cycle cost. So option B is the correct option. Coming to the MCQ number 6. MCQ number 6 says that a machine part will perform its intended function under desired operating conditions over a specified period of time. What is this called? A machine part will perform its intended function under designed operating conditions over a specified period of time. If a machine does this thing, performs its work under a specified condition for a specified period of time, then is the name given to it? Surety, reliability, promise, or guarantee? So surety is not a technical word. Guarantee is also not a technical word. Promise, this is neither the correct answer. Reliability is the word. Reliability is used for reliability is the term used for a machine part when it performs its intended function under desired operating conditions over a specified period of time. So option C is the correct answer. Coming into the MCQ multiple choice question number 7. The ease with which a machine part can be serviced or repaired is known as. Now see, the easiness with which a machine part can be maintained or repaired or serviced. What is it known as? Serviceability. No, this is not the term which I have discussed with you. Easeability. This is also not the term. Feasibility. This is also not the term which is used. Maintainability is the correct one. Maintainability is the correct one. The ease with which a machine part can be serviced or repaired is known as the second one. What? Maintainability. Correct. The ease which a machine part can be serviced. Alright, coming into the MCQ number 8. The property by virtue of which a material does not deflect or bend too much due to the forces or movement that act on it is called. Now this is a particular property. There is a name for this property. What is the property? The property says that the material, if it does not deflect or bend too much due to the forces or movement acting on it, if it has the resistance to this bending, deflection, then we say the property that the material is rigid. Is option B is strength, C toughness, or D wear resistance. So we all know that what that this rigidity is basically what it is resistance to bending or deflection. Rigidity is what it is resistance to bending or deflection. So we can say that none of the other option is correct. Only the option A is the correct. So we can say the correct answer is option number A. All right. Coming into the next multiple choice question. The question is shaft and couplings are considered under shaft and couplings are considered under general purpose machines, special purpose machines, or both general as well as special, or neither general or nor special. What is the correct option? The shafts and couplings are frequently used. They are regularly needed. They are not especially needed somewhere. They are the main part of maximum machines. Therefore, they are kept under general purpose objects or the general purpose machines. So, option A is the correct option. What? Just shaft and couplings are considered under general machines. Alright, coming to the MCQ number 10. Now, what is the MCQ? The MCQ is same as the previous question. This was for a special purpose machine, general purpose machine. Now, this is the question in which it is asking you that pistons, valves, or spindles are considered under. Now they are considered under which category? Pistons, valves, and spindles. Now this valve and spindle as well as piston, they are not needed everywhere. All right. Now these are not considered important in every machine. You don't need it in every machine component. Therefore, these can't be kept under a special purpose machine. Now, if B is not the correct answer, then C can not be the correct answer. And now you have to choose from A and D. Now, since once again I am telling to you, make it correct that what I have told, I am telling you students that I am telling you that piston valves and spindles they are not needed frequently means they can't be kept under general purpose and also this option C both is also not the correct option. So which can be the correct option since they are needed spatially therefore they are kept under a special purpose machine. So option B is the correct option. So all the MCQs, all the 10 MCQs were destined, they were used for making a good learning of the today's video lecture. So I hope you have understood. Now, for your self-study or for getting the content related to our today's video lecture, you can refer these books which are listed here. You can use the book written by Pandya and Shah, and the name of the book is Elements of Machine Design. Then also you can, this is a very important book which the main contents you can get in this book. This is of Tata McGraw publication. It is written by VB Bhandari, Design of Machine Element. Then the book Mechanical Machine Design by Goyal. This also you can refer. You can also refer singly. It is also of McGraw-Hill publication, and the book name is Machine Mechanical and Engineering Design. Then you can also refer Machine Design by K.K. Pujara and Zuneza. It is of Dhanpal Rai publication. So these are the books you can refer for your understanding or for getting more in-depth knowledge of the subject. I hope you have well understood the concept discussed into the lecture. And in the coming lecture, we will discuss more we will go deeper into the concept of machine design, all the considerations which are taken that will be discussed in the coming lectures. What are those considerations? Like aesthetic considerations, ergonomic considerations, machine considerations, and after mechanical properties, that all will be discussed in our coming lectures. I hope this video is beneficial for you. Thank you. Have a nice day.